Okay, this is a fun week because we get to talk about business intelligence tools and take a bit of a break from all the math and intensive stuff and do some more hands-on type of work and actually play with some data. So while there's some concepts to talk about first, a lot of the time for this class is going to be spent just walking through. You'll watch me pull up Excel, pull data from Access. We're going to use some Power Pivot and Power Query features in Excel. And these are all incredibly useful tools that might be extremely helpful for you guys one day. So that's it. Let's get started. All right, so in the business world nowadays, I can't think of a single business that's mid-sized or larger that does not use data analysis, not just for the marketing and research or work that they do externally, but also to help improve and have visibility over their internal processes. So Microsoft and other software companies have created all these suites of tools for analyzing data, and we call them business intelligence tools. For Excel, we have the Power BI suite. So that includes Power Query, Power Pivot, Power View, and Power Map. We call these self-service business intelligence add-ins. So if you need to analyze data for your job, you don't need to call your IT department and ask for special software or ask for help manipulating data. You can use it all native to Excel. There's another tool for SQL Server database software called SSAS and Power BI. Those are other offerings from Microsoft. Power BI is the kind of competitor to Tableau, which we are also going to be learning about today. So for data visualization, this has become a big thing for businesses as well. We want to take Grana and show it in new and imaginative ways. So instead of just these ugly pie charts or really crowded Excel charts that are difficult to make attractive, we have other software packages like Tableau, which, while more expensive, the non-free version, allow us to join data, quickly manipulate it, pull it directly from a whole bunch of different sources, including like Oracle databases or Excel files, and then quickly visualize our data in hundreds of different ways. So we're going to look at Tableau Public because it's free and it's non-Microsoft. It's easy to learn and it's incredibly powerful. And if you do work for a large company or end up working for a large company and you're doing any sort of data analysis, there's a good chance that you will run into Tableau. So having a basic understanding of how it works and what it can do is going to be really important for you moving forward. Okay, so we're going to be importing data into Excel using Power Query. Data sets that we analyze are often not stored in Excel workbooks. So we need methods to get data into Excel. And they have made this very easy for us. They have this feature called Power Query. But before we can talk about what that means, we need to talk about relational databases. So in every other chapter, we have pulled flat files of data or single table databases in order to perform regression or calculate confidence intervals or whatever else we were doing, all of our hypothesis testing. So those are just data in one singular rectangular table. So a database is just a set of related tables where each table is a data set of the type that we've discussed in previous chapters. And because the tables are related, a database with related tables is called a relational database. So there's sort of two questions that branch off from this. Why are data often stored in multiple tables rather than a single large table? And then how are the tables related? And the answers to those two questions tell you everything you need to know about a relational database. So if all of our data was stored in a single large table, then our database would be huge and we would drastically increase the possibility of errors. Since every individual item is given a unique line or row, If one individual's information changes, like their address, then that change has to be made everywhere else in the database. So the solution is to split the database into separate tables that are related and use keys or identifiers to help tell our software program how to join those tables back together. So a primary key serves as a unique identifier. So if we had a table about employee information, their key is usually something like their social security number, or like their last name with some kind of numeric suffix, just something that's unique to that, that row. An auto number key is a primary key that just automatically assigns integer values. So the first entry will be 1, the next will be 2, 3, so on and so forth. And a foreign key is a field in a database table that is related to a primary key in another table. It doesn't have any intrinsic meaning, it's only used for lookup. Usually our primary and key fields are pretty meaningless, especially if you're like auto numbering or like a social security number. It doesn't provide us any value. It's just for relating the tables and for ensuring that all of our entries in that table are unique. The whole purpose of separating data in a relational database is to avoid redundancy. So we're trying to maximize the efficiency of our database and minimize the amount of data that's being stored. So each table contains data about some specific entry. So you might have customer data, product data, order data. So you think about the order data, there's likely a field that specifies what product is being ordered and which customer purchased the order. So if we have a relational database, we can tie information about the customer to that order, like the customer's address. If we want to look at our orders from various locations around the country, we can make that connection between the order, the customer field in the order table, and then be able to pull that information without having redundancy. And then the primary and foreign keys are necessary for us to be able to tell Excel or Access or whatever program we're using that, for example, this customer ID ties to this customer in this other table. So we can have a one-to-many relationship between two tables. So that means a record in one table can be associated with many records in another table. So for example, each customer in the customer database table might be associated with many order records. Hopefully, if you're a company, they have many order records. So that's a one-to-many. Each customer is only has one entry in their table, but they might have many references in that order table. A many-to-many would be where you have a relationship between two tables where each record in each table can be associated with many records in the other table. So that looks like orders and products. So a specific order could be for many products, and a product could be a part of many orders. The tables are related with a linking table or a bridge table. So that might be, for example, a table called order details, and that will have at least two foreign keys, one for the other and then one for the product and possibly nothing else. So many-to-many relationships can get a little bit complicated when you're trying to join data. So generally we try to connect the data through some kind of bridging that helps us prevent issues in our program. So we can look at our tables and the relationships between them using a relationship diagram. And when we go through our examples, you'll see what this looks like in when you have multiple tables. But this is between donors and donations. So we're looking at a one-to-many. So each donor is unique and is associated with a donor ID, but may have been made multiple or many donations. So in this case, if you look at these two tables, you can tell very easily where your which keys you're going to link. This primary key here for donor ID is going to link to this foreign key donor ID in the donations table. All right, so now we have products, order details, and orders. And this is the sort of many-to-many bridging that I was talking about. So our products table lists all the information about each individual product. Our orders table lists each order, which is uniquely identified by the order ID and provides information about the order. And then this order details contains the information about the order ID, the product ID, and then a couple of other information, looks like quoted price and the quantity ordered. So the product ID is tied to the order details table, and then the order ID from the orders table is tied to this through here. So you can see if you have a lot of tables, how this could get pretty complicated. Up until recently, relational databases stored their information in what's called a relational database management system. It's just the software that creates and manages databases. The most relevant example would be Microsoft Access, which you may or may not be familiar with, but it's a database, a desktop system where all your database files can live on your hard drive. Nowadays, the server-based systems are more common. So usually these are managed by a database administrator, and you would not be able to access the data unless you had credentials for that server. So you may have heard of some of these. Oracle databases are very common, SQL servers, and then there's also MySQL, and then IBM has a DB2 system as well. So these are just server-based systems. The data is not on your hard drive, it's on a server somewhere, and then you have to log into the server to access it and to query against it. So our problem as analysts is that our data is typically stored either on a server or in a relational database, but we want to do our analysis in Excel. And we're not going to worry about pulling data off a server because that's beyond the scope of this class, but it would involve querying a server, often using what's called SQL. But we're going to practice pulling data from Access and not worry about the server side of it. And I've said the word query a few times. A query is specifying, it's telling the software program exactly which data you want to import into Excel. So queries are so common that the actual language for querying data is about 30 years old and is called structured query language, or SQL. Some people say SQL, I say SQL. The power of SQL is that it can be used to query any relational database. The language varies very little between systems. However, if you use Excel, you may not know SQL, so tools like Power Query were designed to make querying easier by creating basically a user interface between you and the SQL code so that you don't have to know SQL. It has always been possible to create multi-table relational databases directly in each cell using VLOOKUP, but it's cumbersome. And Excel has a 1 million row limit, so so you might have too much data to fit into that. Everything we do is going to be in Office 365. If you're running off of an older version of Excel, you may run into some slight variations on your screen. You might have to Google how to do it in Excel. Hopefully all of you have Excel 26, at least a 2016 version or higher though. If you don't, then things are going to look a little bit differently, and you may be limited in what you're able to do. Okay, so now Excel has this thing called a data model. So when we run a query to import data into Excel, we have to decide where we want to store the data. It used to be you could either store it in an Excel table or in a pivot table. Excel table is fine unless it's really large. A pivot table is fine if your ultimate goal is just to make some filtered pivot tables or some pivot shards. A data model mimics the behavior of a relational database, but within Excel. It's actually really cool. It's it basically eliminates the need for Microsoft Access because, well, for data storage purposes, there's a lot of other things you can do in Access that are very cool, but it mimics the back end of Access. It stores related tables in a special compressed format, so they're not stored in an Excel worksheet. And then you can use those to create pivot table reports. So you can store millions and millions of rows of data inside an Excel workbook and then use Excel to analyze the data and not run into any issues. And even better, you don't need to use VLOOKUPs. And once the data is in Excel, you don't need Access anymore. So that's what we're going to be doing today. Before the data model, you had to use Access and then manipulate your data in Access and then import it into Excel. So we're kind of skipping a bunch of steps. All right, so let's get into the examples because this is going to take us a while. I'm walking through them as they are in the book. You can follow along if you want, or you can just watch, like I said, and then pull these files and try them out on your own later. And I will post the video as well, so that you can always pull this back up. Okay, so we're going to take a database, Contoso, and it's just a practice Access database that actually Microsoft created. And we're going to use Power Query to import the tables and then store them in a data model. So there's a couple of ways to do this, but the first thing you're probably going to have to do is see how I have this Power Pivot tab here. It wasn't there. So you're going to need to go to Options because this generally doesn't show. We're going to go to Customize Ribbon. And I want you to turn on both the Developer tab here, so it'll look like unchecked, check it. And then I also want you to, okay, so then you click OK, and your Developer tab shows up here, so that's good. Then, see this add-ins, COM add-ins? Click on this, turn on the Power Pivot. If you decide to play around with Power Map later, if you have geographical data, you can turn it on as well. But for right now, just to avoid lots of things going on, I'm gonna just turn on Power Pivot. So it will look unchecked, we're gonna check it. And then we get access to it up here. So we're gonna need this later. Okay, so back to home. Let me see if I can move this thing. Okay, so there's a couple of ways to import data. And before we do the Power Query, I just wanna show you how this works. So one way we can get data is from here. So we can pull in from a text. You can do it with PDF, but I gotta warn you, this can get wacky. We can pull from a database, from Azure. So this is where you go to connect to a file. There's some options right here. It's common to pull from a CSV file. If you are trolling the web for or crawling the web for data, oftentimes it will set you a CSV file. So you can just quickly do it from here. What else do I want you to know really quick? I think that's it. So we're gonna go, oh, and then there's, yeah. So let's see. In your assignment, you're going to need to do it this way, but we're going to use Power Query for this example. So you can play with this, but slow. This is one way to do it. It will pop up it'll ask you to find your file. And then it will pop up a little wizard. And then you can tell it which tables you want to pull in. And you can manipulate the data before you do that. So I just clicked the transform button. And now I'm getting into the Power Query at this point. So you probably don't want to go into here, but you can remove columns. You can do some, there's a lot in here. I'm trying to think if there's, I just want you guys to be aware of how to get to it from this part. But now we're gonna leave this and follow our other steps. Okay, so we've turned on our Power Pivot here. Okay, so we're gonna go to the data ribbon first. We're gonna click Get Data. And we're gonna follow what I just showed you. So we're gonna find our data and import it. When we pull up our navigator, we're going to select all, we want all of the tables. So I want to be able to select multiple items. So I'm going to turn that option on up here. And I'm going to select all of my tables. And then I'm going to come down here to load and click load to. Okay. So this is, when you get to this stage, this is where your homework diverges. At first, your homework is going to tell you to just put it into a table and not the data model. So you would select table up here and you would uncheck this. When you go to do this as a Power Query to compare the two methods, you'll go to only create a connection and add it to the data model. So we're telling it, if we were to do both, if we were to put it in a data model and a table, we're actually duplicating our data and because we're storing all the data in tables and also in the data model, and that's redundant. So we're not going to do that. We're just going to store it in our data model. Okay, so we hit OK. And notice that I don't have my tables down here as sheets. That's because the only way I can see my data is through this data model. So this is why we turned on the Power Pivot tab. Now it's loading, so we're gonna have to give it a second. So what it's doing right now is it's talking to the Access database that we queried from and pulling the data in and storing it. It's compressing it and then storing it. So you can see it's already done thousands of rows. Okay, so it's done. And when we look at this, we can say, okay, this looks pretty good. You can even look at your tables to make sure they imported correctly. So I have my product, I have 8 product categories in this table. This table lists all my products. This looks good. It only shows you a couple of rows just so you can kind of check and make sure these look good. Okay, great. I'm going to close this. If I want to see my data, notice that, like I said, I can't see anything in here. I have to come up here to Power Pivot and click Manage the data model right here. So if I click Manage, I get this nice screen that pops up. And it will tell me, it looks a lot like Excel, except now notice it's different up here. So this is my data model. All my data is down here. This is great. If I want to see how my data is connected, there's a little toggle down here between the table view and the relationship view. So here's my 5 tables. As of right now, you can see that none of them are linked to another, and we're going to have to tell it to link them together. Okay. Let me just make sure. Okay, so we're going to do that in a second. We're actually going to add some more data to this data model. So I'm going to close out of here, back here. I'm going to go to my Excel window, and we're going to insert some data a different way, just to get used to doing this. So we're going to go to Data, and then we're just going to click from Text or CSV, and we're going to do Geography. import. And it's thinking, okay, this looks good. If for some reason you have a CSV that's not comma delimited, you can change that here, but it usually is always comma, and you'll know if it's wrong because your data won't look right. This looks fine. Load to. And then I believe, yep, we're gonna go only create a connection and add it to the data model. See, it tried to put it in as a table because it came from a CSV file, but I don't want that. I just wanna add this to my data model. So it's adding down here. And then we're gonna do one more import from a different Excel workbook. So for that, we go to get data from file from Excel workbook. I want the stores information. Sure, that's right. Okay. There's only one thing to select, so here it is. If you had different tabs in your workbook, you'd get multiple tables, one for each worksheet, and then you might need to select multiple. Just looking through this looks fine. I'm going to say load to. Again, it's going to try to set it up as a table. I don't want that. I want to add it to my data model only. I'm not trying to have data in two places. Click OK. Now I have all the tables that I want for this analysis. And if I look at my stores data, it's giving me the store key, the store name, some information about the zip code, their phone number, address. Oh, look, geo data. All right, interesting. Okay, so now we're gonna go back to our Power Pivot ribbon tab and click Manage, and we're gonna link up all these tables. So I'm gonna go back down here in this little lower right corner and click on the relationship view. And I don't like that I can't see all my tables. So I should, there we go. I'm gonna move my tables around a little bit. And I don't like to have my wires crossed either. So let's see. We have dates. I'm just gonna rearrange my tables a little bit. Sales. I have my stores. Geography. You don't have to move them around, but I'm doing this because it will be easier to follow when I link everything together. All right, so now we need to tell our tables what's what. So in this table, the primary key is date key, and it's tied to the date key in sales. This one-to-many is good. That's what I want. There's also a store key here that ties to this store key here. And the stores have each a unique record, but may be listed in sales multiple times. So this one-to-many makes sense. I also have my products, which are unique, and they may have many sales. So this should turn to be a one-to-many as well. One-to-many. See the one and the asterisk means many. So that's, and then it's telling you the direction as well. So this is good. That matters. So make sure that you think about these things when you're connecting them. I also have my geography table over here. So my geography key is unique and ties to the store geography key. So this is one-to-many the way I want it. And then we have this product. So each product fits into a subcategory and a category. So starting at the category level, each category key has multiple subcategories associated with it. And then each product has, or yeah, each subcategory, sorry, has, oh, I clicked the wrong one, I'm sorry. Each product subcategory has multiple products underneath it. All right. Okay. Now all of our tables are linked together. So now we can, this is where the magic is. So this example is 4.1 in your book, and it has just shown us how to import data from a variety of different sources and how to view that data in Power Pivot and how to create relationships between the tables. All right. We're going to set this aside for a second and do a slightly different example. So I'm going to close out of here. It's going to save all that for me in this, and I'm just gonna rename this. So that we can come back to it. And then we're going to move on to example 4.2. I think we can just move on, but I'm just gonna check the slides really quick. Okay, so our objective for 4.2 is to create another data model by creating a pivot table and then relating the two tables. So we're going to do this from a existing file. So there's a file that I provided, baseball salaries with team info 1. Not the finished one. And while that opens, okay. So in this file, your source is here, just so you know. We have this salaries table and this teams table. The tables on the two sheets have been designated as Excel tables. So they're named tables. This table is named salary table, and then the other table is named team table. The team table has a row for each of the 30 teams that lists the team's name, the team's division, and the team's league. The salary table has a row for each player, which lists his team, position, salary. So in terms of the database, the team field is a primary key for the teams table and a foreign key for the salaries table. However, these tables aren't related yet. So we're going to use a pivot table to create a data model. Okay, so we can select just any cell in this table, in the baseball salaries table. And then we're gonna do insert pivot table. And we get this dialog box. So it knows we want the whole salary table, so that's good. We do want it in a new worksheet. And then right down here, we can add this data to the data model. So we're going to check that option. And then we're going to hit OK. All right. So a new sheet with a blank pivot table opens. And then if we were to open the Power Pivot window like we did in the other example up here, we would see in the data model that we now have the salaries table. So that's good. Added it to our data model. So let's drag salary to the values section here. Okay, so at this point, you can see that we're in this active, all we see is the salary table. If we click over to all, however, we now have this team table showing up here as well. So if we drop this down, we can actually pull from this table and check the division. And now Excel is saying, okay, you probably need to specify a relationship between these two tables because you haven't done that yet. By selecting a field in the team table, it is smart enough to recognize what we're trying to do. We're trying to relate the two tables, but it wants to make sure it did it right. And if we look over here, it did it right. But we're gonna tell it, go ahead, auto detect. Generally, auto detect works just fine. If you wanna check that, that you can click manage relationships and it will open up that Power Pivot window and show you, or actually, I'm sorry, it doesn't. It opens up this window right here, the manage relationships window, and it tells you the two tables, and then you can click edit and you could tell it, no, they're not related, but it's just telling you from the salary table, it took the team name team and tied it to the primary key team in the team table. So that's what we wanted. So we're good here. And now look, we have tied the two tables together and we're able to look at salary as a function of division. Very, very powerful. What else can we do? For right now, nothing, but watch this. I'm just gonna delete these because I feel like it. And check it out. My pivot table still exists because we saved everything in the data model. We don't even need those sheets anymore. So that's fun. Nice and clean. Let's see, I think we're gonna come back to this maybe. Maybe not, can't remember, just in case. All right, so I think we've got a handle on creating data models. All right, so I guess let me just Power Query. Let me just point out a few things really quick that we didn't. There were so many features there, just for your knowledge. With Power Query, you can import data from more sources than you ever could before. Many different types. So check that out. If you ever have like an obscure, you can even import from the web, which I think we might do at some point. So very powerful tool. Once you locate data of interest, you can use this query editor feature to shape data before it's imported. So there's that feature. And then your queries are stored in step-by-step fashion so that they can be modified and reused later. So if you make frequent queries from the same basic data source, you don't have to start over every time with each query. You can save the process that you use to import it, and then it will remember it. Okay, so we're gonna go back to our Contoso data, and we're going to do that. We're gonna shape our data with a Power Query. Okay, so to do this, we're going to open up a new file so I can show you what that looks like because we already imported everything into this one. Okay, so remember to import data. We go to data, get data. We're getting it from a database. So I'm going to click from Microsoft. Now we're going to get back to the navigator window. And then instead of just loading them in like we did before, we just selected the 5 tables and we said load to, and we put it in a data model. We're going to select multiple items. We're going to select all 5. And then click interestingly, I think it's this transform data button. They say edit. I think they changed the name of the button. So now we're in this editor, which is what we wanted. So the button name was transform. In your textbook, it says edit. They changed the name of that button. So instead of clicking load to, we clicked transform, and now we're in this Power Query editor. So I showed you this a little bit before, but I can choose columns and then see a list of all the columns in the table that I'm looking at. And I can actually uncheck ones that I don't want. Let's see, I could split. Oh, here's something cool. Let's do this. This is useful. Let's say you have a bunch of people's names. Well, I'm not gonna get, actually, I don't have a table like that, do I? Maybe under here. Okay, if we had like customer data, we could split there's a split option right here, split column. So if you had names and they were like Scott, John, you could split all those names into first name, last name with a delimiter. And you would tell it, okay, it's the comma, and then you would tell it how to split, and it would split your into the appropriate number of columns. So that's pretty cool if you wanted to separate out your first and last names. What else could we do? We can filter. We can mess with the date types. We can change the data types if it looks like something got carried in wrong. Like maybe it's supposed to be numerical, but it got put in as text or currency. We can replace values. So if you know that you want to replace like all yes responses with 1 or something, you could do that all in here first before you send it out. And then you can, let's see, I think that's all I want to show you. In this transpose or transform tab up here in the ribbon, you can fill. I already showed you split column. You can pull out just like the first 5 characters of something, or the last of some, or some range in between. You can show time only or just the hour, minute, second. This is a date, so this, I have a date field selected, so it's telling me I have some options here to play with. Okay. So that's that. I'm actually, let's see. There's a lot of stuff with this tool. I wouldn't expect you to master it for this class, but if you were to use this this process a lot at your work, you would definitely want to get more familiar with the Power Query editor. And there's lots of resources on the internet for that. So the close and load option uses the current default setting to return the data to Excel in some way, and it's not recommended that you use that. This right here. It's better to do close and load to, and then you get that dialog box and you can decide how you want the data imported. So if you just do close and load, it kind of decides for you, and generally it does this, it puts it in a table, but generally we're going to want to do a data model instead. So if you choose close and load to, you have control over what happens with your data, and that's what we recommend. Okay, so I'm not going to save this because we have a nice file already with everything linked. I just wanted to show you the Power Query editor. Let's pull some data from the web. So I need this link here. Okay, so to do that, we go to I'm just going to do it within this file. Data from web right here. So if you find a website and it has a bunch of data that you want, and actually maybe I should show you what this website even looks like. Probably should make sure that the website is still existing. Cool. See, so this is some site and you can search on all this information. So we can just tell Excel the website that we want to pull data from. And then we're going to click OK. Okay. Oh, interesting. I guess I'm going to be anonymous. Some websites may not allow that, and you may have to put in, you might have to connect differently, but for the sake of this example, oh, it didn't, interesting. It didn't pull, didn't like it. Let's try this again. This may not, a lot of times if you find data on the web like that site, you can actually export to a CSV or Excel file and then you wouldn't have this issue. So I recommend that, but I just wanted to quickly show you this feature. Even if it doesn't work for us today, hopefully you get the point. Yeah, okay, it didn't, I was hoping it would give me the chance to reset that screen. Let me try one more time in a blank Excel spreadsheet. From the web. No, sorry guys. Something between the time when the book was posted and the way the site is designed didn't like me connecting as anonymous. So I won't be able to pull it up, but you can look in your book. It basically just the same steps as before. It would just show you the table with all the data and be good to go. So you can always try that if you find a website that has a nice table like that as another means of importing data. Okay, this might be a good place to take a break. We're going to move on to away from importing data and onto analysis. So let's take a 10-minute break and then come back and move on to that. All right, now we're going to move into analysis. We're going to use our database that we created before. So if you remember, we just connected all of our data, and I'm just checking to make sure I'm in the right file. So I opened my data model, everything looks good. We are going to use this, this feature. They have this relatively new thing called data analysis expressions language to help perform calculations. It's possible for us to create calculated fields within pivot tables, but for regular pivot tables, what that does is nothing compared to what we can do within this Power Pivot Editor feature here using this DAX language. So there's a quote in the book: business intelligence consulting firms have started to specifically target people who know DAX. As in, if you know Power Pivot, you are their ideal candidate. Doesn't matter whether you were a business intelligence professional yesterday or not, just that you know Power Pivot. So We're gonna look at this, this data analysis expressions language and illustrate some of the things it can do. And then it's up to you guys to pursue this further if you think that it will be useful for you in your job functions. All right, so first let's talk about a calculated column before we get into this, because we're going to be adding calculated columns here. So a calculated column is a new column in a table of the data model. It's based on the fields in a current table or related tables. A measure is a summarization of columns in the data model or a function of other measures that is intended for use in the values area of pivot tables. Both calculated columns and measures are created using DAX formulas. Okay, so we are going to stay here. And then let's see, I think we might, yeah. Okay, so we're going to create two types of calculated columns. The first one we're going to call profit. It's going to be sales amount minus return amount minus total cost. Let me go to sales. So in this table here, I click down below on the sales tab. So profit, and then we're going to create another column after that. So let's do profit first. Okay, so we can click anywhere in this blank column over here where it says add column, and then type an equal sign. And you can see my editor up here. So it looks very similar to what we're used to in an Excel spreadsheet. And then we're going to click the sales amount heading, see it, and then it populates up here, minus return amount heading, minus total cost. And then we're going to hit enter. It's thinking, because what it's doing now is it's calculating this for every row. And then there we have it. We've just created a calculated row. I don't really want it to be titled calculated column 1. So I'm going to right click this column heading and click rename column and type profit and hit enter. Okay, now I have a calculated column. There's another way to do this. Instead of having to type that all out, I could have just written my formula this way up here. So just watch the screen, because I'm not going to actually do it because we already have profit calculated, but I could do this profit colon equals, and then I could have put in my formula that where I clicked. So sales amount minus return amount minus total cost. And then I would have hit enter, and then it just would have, all that's doing is telling it to rename the column profit while it does all the calculations. So let's do another column, and we'll do it this way. So, oh, I accidentally deleted out the formula. Let's fix that. Well, now you get to see it twice. Sales amount minus return amount minus total cost. Okay, enter. Oh, I have two equal signs. And the reason it takes a while is because it's doing 33,000 calculations. Okay, cool. All right, let's use a function specifically related to this DAX language. So one thing to note when we create a profit though, really quick, you notice that you can't create like a partial column. If you create a calculated column, it will fill in a value for every single row for the entire column. And so that's the difference between a column, or one of the differences between a column and a measure. All right, so in this second column over here, we're going to use this function called related. There is no counterpart in Excel. So if we were in a regular Excel worksheet and we tried to type in the function related, nothing would come up. So what we're going to do is we're going to pull in a field from another table. So because our relationships are defined, we can do this. So in the products table down here, click anywhere over here where it says add column. And then we're going to type in product category and then the colon. So we're telling it, I want to name my new column product category, and then it's going to equal, and now we type related. If we spell it right, it'll work. I'm going to select related here. Now look at, it's giving me some options. It knows based on the relationships that we defined earlier that the product ID or the product key is tied to product category, which is tied to product subcategory. So let's pull in first. Let's see, we need to pull in product category name. So I just double clicked that and then it popped up here. Now I need to close out my parentheses and then hit enter. So this is what we've done. We have this information in two separate tables, but each of our products is associated with a product category from the product category table. So we've just told it based on my product key, go back to here, look at the product category label, and then pull the product category name so that we don't have to click back and forth. So we can do this again and pull in the subcategory name. So let me make sure that's what we want to do. Yep, product subcategory name. So same thing. So now we're going to name this product subcategory colon equals related, again with spelling, subcategory name, finish out my parentheses and hit enter. It's doing its math. All right, we got it. Looks good. Okay, so why would we do this if we already have this information in two related tables? Weren't we trying to not have redundancy? Yes, but when we use the data model to create pivot tables, now all of our product information that we want to do analysis on is in one table. So this is beneficial because it allows, for one reason, if we were to create a pivot table from this table, it would just be one table listing in our field list, and that if we are sending this to other people, it just makes it a little less confusing for them. They don't have to pull from two different tables. So that's one reason. The second reason is that we can now build a hierarchy. So if we go to our diagram view down here, and we hover over our products table like this, there's two buttons in the top right, this create hierarchy and this maximize. We're going to click maximize first just so we can see everything. And then so now you see we created these these two, product category and product subcategory. Now if we do create hierarchy, which is the other little button up here, we're going to call our hierarchy product structure. And then we are going to put in our structure. So the way this works is we have product category. Okay, I just added it. And then we have product subcategory. And notice how I did that. It might take you a minute to get the clicking right to play with it. I want to put them right underneath each other, so I'm looking for that little black line. Brand name and then product name. Okay, so this is telling it that for every category, there are subcategories that contain brands that contain products. So we have this product structure now that we've specified. Let's restore the table back down, and we will see how this hierarchy is going to help us when we move back to our Excel spreadsheet into a pivot table. So a little bit more about other functions. You can manipulate dates with some of the DAX functions. You can use a lot of formulas that look like Excel formulas, including like if, which we've used before. Yeah, this is just like the tip of the iceberg, but to show you the potential of this application. So let's do some measures before we get into anything else. So the book argues that measures are even more important than those calculated columns. They are summarizations of the data in the data model that can be placed in the values area of pivot tables. Measures can be created implicitly or explicitly. Given the data model we've developed so far, we could just create a pivot table and drag profit down to the values area, and then it'll sum automatically. So we'll see profit broken down by any row or column fields that we add in our pivot table. But what it's really doing behind the scenes is creating this sum of profit measure on the fly. So we can explicitly create these measures in this tool and then have a little bit more power in Excel. So to do this, we're going to enter into a table in our data model. And the best practice is you can do it in any table, but you should do it in the one that's most closely associated with the measure you're about to do. And you'll see what I mean here in a second. So let me go back to this view here down. And then we just use measures in the pivot ribbon tab as another way to do it. So let's close out of here and go to our Power Pivot tab. So see the calculations here, measures. So we're going to create a few measures. We're going to click. Actually, we're going to open back up our window here. Okay, so we're back in the Power Pivot window. We're going to go to the sales table. And then down here, see how this is a split screen? In one of these cells down here, we're going to do a measure. So we're going to select this cell, and then we're going to name our measure revenue. So the same syntax as if we were naming a column, colon, and then sum. So revenue is the sum of, and we're going to have to, oh, actually, I think I can just, I want the sales amount. So, oh, it didn't let me do it. I'll have to type it in. Okay, fine. So I'm referring to the sales table, and then I need these brackets. I want the sales amount column, close bracket, close parentheses for the sum. And I think that's it. So then we hit enter, and it should pop up with a number once it calculates. Oh, I forgot something very important, an equal sign. It doesn't know I'm on a calculation because I didn't put equals in there. Okay, so now it's thinking. Okay, if I were to expand this column, you can see that it calculated this big number right here. So it calculated the sum of the total sales. So that's what we wanted. The cell below that, we're going to do another one. We're going to do cost colon, and then don't forget the equals sign. This one is going to be equals the sum. And now this should work because okay, here we go. So before I didn't have the equal sign in, which is why it wasn't letting me select my fields. You don't have to type in your fields if you do this correctly. So I want the sum of total cost from my sales table, and see how it's giving me all the tables. You kind of want to do these in the relevant tab. So that's what we were talking about. I could do this over in products, but it doesn't really make sense because I'm using the sales. So I kind of want to keep my measures tied to the appropriate table, just for good practices. So I want the total cost. And then I'm going to close that and hit enter. And then we're going to do one more. And we are about to, just a minute. I'm going to have to pause for a second because there's someone at my door. Okay, sorry about that. Okay, so cost finally calculated. And then for the third measure, so I have this calculated metric revenue, and I have this other calculated metric called cost. I can actually use these measures now in formulas. So I'm going to, in the third cell, name a measure ratio. And it's going to be revenue, which you can see now populates as an option, divided by cost. So when cost pops up, I'm going to double click it, cost. And I want this sum. See, this is how I know it's a measure. Hit enter. So now I have revenue, cost, and ratio all calculated. Okay. Now we're going to go back and create a pivot table based on this information. So let me close out of here. I'm going to use the data model to create a pivot table. This worksheet's blank, so I'm just going to create it in this worksheet. And look, here's all my tables. So if I click under sales, look at what I have now. I have all my original fields. I have my calculated columns, profit, and then I also have my measures, revenue, costs, and ratio. You know their measures because they have this little f of x little function notation right next to them. Okay, so we're going to drag the ratio measure to the values area over here. And then we are going to drag the product structure hierarchy from the products table. Okay, so here's my product structure hierarchy, and I'm going to put it into rows. All right, check this out. So now I have my ratio of whatever that was, revenue and cost, by category, by subcategory, by brand, and then by product. So that hierarchy that we built, we can now use in our pivot tables. Super, super, super helpful. All right, let's see, what else do I want to show you? Okay, so aside from the ability to drill down, those measures, I guess the other key point here that we calculated, they're smart enough to know that when you apply another category to your data, it will recalculate based on that category. So it's calculating the ratio measure that we added for each level. So we made a global measure and then it applies the filtering to it in the same way and then recalculates, which is awesome. Okay, let's say that our boss tells us that we calculated revenue and costs incorrectly. And we don't have to start over. We can just edit the measures either using the manage measures right here. So let's see, they said what was wrong? Revenue should be the sum of sales amount minus the sum of the return amount. So let's edit it. So this pops up your little editor. And from here, we could correct it. So we could rename it net revenue. And we could call it sorry, the example is going through a lot of stuff. I don't think I want to go through all of it, but we'll just do one of them. So we're going to say the revenue should be the sum of the sales amount minus the sum of the return amount. So you can see as I'm typing, it's starting to pull up. So I want this return amount here from the sales table. So this is how I can correct this, and I could also change it and make it currency if I wanted to. So now see, it's telling me I changed my data model. It's giving me a warning, and I have recalculated revenue, and I also renamed it, which I didn't mean to do. Okay. So we fixed revenue. We can add new measures this way instead of going back into the data model. So I can create a net revenue and have it be revenue minus the return amount. So I can do it like that. What else can I do? I can create year to date, call it net revenue year to date, and have it be equal to, and there's a function called calculate. And then it takes in some, it's gonna do some filtering for me. So I want it to take in net revenue. And then we're gonna do this dates year to date function. And again, you would have to look up like all these. I'm selecting the date key from the dates table. There's so many functions. I'm just showing you some of them to show you kind of what I can do. So year to date. So this is gonna return, oh, it didn't like it. Net revenue, am I missing? Oh, I'm missing a parentheses. Okay, so let's see. You could do percent changes. So you can take a look in the book at some of these examples. Let's just stop there for the sake of time and close this and go to our year to date and pull that in. I must have done something with the formula. All right, no big deal. Here's our cost. Here's our revenue. And then our ability to drill down. All right. The other thing that we can do is we can take, for example, the calendar year, and we can make it a oops, I didn't want to add it. Okay. We can filter up here on calendar year, or where's the thing? You can also come through this way. And let's see, we can, or a nicer way to do this is to go to your tables up here under design, or no, analyze, and insert a slicer. So a slicer will allow you to filter, but it'll just look a lot nicer. So if I do calendar year like this, I get the options up here to only sort by 1 year. So you see the numbers changing dynamically. So this is nice if you're presenting this to somebody and you want to give them the option to filter like this dynamically. Okay, so that's slicers. That's a useful thing to know. There's a lot of other stuff that can be done, but we're going to move on to Tableau Public for now. All right, so to get Tableau Public, you have to go to the Tableau website, and you can Google Tableau Public and it'll take you right to the page to download it. So you'll need to download it and then open it up once you get the file on your, or the program on your computer. And Tableau Public is free. So once you open up Tableau Public, you can connect to a couple of different kinds of files. We're going to connect to an Excel file. So we just click Microsoft Excel, and then I'm going to go to my data, and I'm going to use this info baseball salaries with team info 2 file. Okay, so when I click OK, Tableau is going to read open this file, and we're going to get a connection to that Excel file. So all the Excel sheets are listed here, and we want all the salary sheets to be joined with the team sheet. So to do this, we're going to select all of these sheets by holding down Control and selecting them. And then we're going to drag them over here. We're going to give it a minute. Okay, so this created a nice little union of all those tables where all the dates they're just stacked on top of each other. And then we're going to take the team sheet and drag it to the right of the salary sheet to create a union. So this is going to join all of the salary tables to the team's key fields for each sheet. And Tableau Public is really smart. It knows what to do. It's confirming team matches with teams. I'm good with that. If you wanted to pull up the union, you could see it right here. Okay. So the only thing is it didn't team to team. It hasn't done it yet. So let's see. It should have just picked it up. There's team. Sorry guys, 1 second. I'm noticing that my year table looks funny, first of all. I guess it doesn't matter. Teams. Oh, okay. I'm going to convert this to a union. Let's see if that helps. It should be pulling over all my player information. Okay, so I have my salaries, my team, all my fields are right here. It's telling me that some of these are textual fields, some of them are numerical. This one is, this little symbol here is geographic. And just, I would have expected this to look a little bit differently, which is why I'm still fussing with it. I'm gonna try one more time. I don't know why this is not doing what I want it to do. Union. take all these off. Try this a different way. Okay, I don't know why, this is what I wanted. So now I have the year. So I just used the new union to pull all the tables together instead. And then now I'm getting my name, the team, position, salary. So now I'm getting the combination of all the fields that I would have expected. Okay, so I'm going to go to sheet 1 down below. Now I have this nice, this is what I wanted before. I have this nice table, my geographical data, and then my salaries and year and measures down here. Okay, sorry about that. I don't know, it should have worked either way, but sometimes with these software programs, you have to get a little creative, so. Okay, now we're gonna create some charts using Tableau. So this is the fun part. Each sheet opens up and is kind of empty like this. And we're basically just going to practice dragging some data around. I strongly recommend that you just follow the steps in the book exactly. So we're going to create a map of the US and Lower Canada, and then show where the teams are and size the team for relative total salary. So it sounds complicated, but it's not too bad. So we're going to take this country to, I'm going to drag it to detail. It's going to think for a second. Okay, and then I'm going to take state, province. Okay, so that pulls up that. Then I'm going to take city, and then team, all to this little detail marker right here. So now I have a map of where all my states are, and then where my teams are. Okay, but now I want some more information. This is fine, but it's not quite what I want. So I'm going to take salary, which is down here, and I'm going to move it over to color. All right. I'm going to click on this and I'm going to fix the opacity down to 50. So I'm really just showing you different things you can do, different functions. There's so much stuff in Tableau, it's hard to, but if I want to change this color scheme, I don't really like the blue. Let's do red, where darker would be larger. So if I look here, like lower salaries are lighter red, bigger salaries are darker red. I'm going to apply those things. Okay. What else? Oh, I wanted salary by color, but I also want it by size. So I'm going to drag it to the size as well. I'm losing some features for some reason. What happened to my dots? I'm going to take that off for a second. I can also add filters. So for whatever reason, we can sort by division. I'm going to remove this. I don't know why. I'll play with that later, but I want to show you that you can add filters. So I can add a filter over here, which in this case is division. And then if I want to see it over here so that I could just take out an area, I can do that. So if I only want to look at like a couple of them or all of them or just the east, I can do that. So that's what the filters is for. I could also filter on year. So our years, it's treating like a number, see? So let me see if it will help to come over here in our original data and change this to date. And then if I go back, I should be able to filter now. There we go, on years. I don't know why it didn't like that. I would have to look at some of this data. I'm gonna remove that filter because it did some weird stuff. Okay, and then if you are playing with data, or you're playing with this and stuff gets messed up, like you've seen a couple times I dragged something over and it didn't do what I thought it would, you can either Control Z for undo, or you can go back with this arrow up here. And you can also look and see there's different things available to me. So it assumed I wanted a map, but I could ask for like different, it's trying its best, but the data, the way we have it is really best suited for a map. And so now I've made a mess of all my stuff. So I'll just undo, go back to my map. Okay, and then when I cursor over these points, it tells me information about that team. So what city, country, and state, province, and then the calculated salary, which is I'll have to work on the union, but the salaries are here. So if you don't want a map, if you just wanted to pull, for example, for each team, oh, that's name, never mind, that's every player. I don't want that. Team, and then you're say, let me see the total salaries. You can pull it in like this. There's not a lot of information here, so we could have done it by team and then position. And then if you create a table, it will also give you suggestions for how to view these things. So this is each team and then their total salaries by position. This is kind of a lot to look at, but it's also interesting because you can see in general pitchers comprise a lot of the total salary payments for these teams, whereas like the catchers don't. So it's kind of interesting. How else could we look at this? So this is telling us that the Los Angeles Dodgers pitchers of all the Major League Baseball salaries is the biggest amount. And then it kind of just drills down. Another interesting way of, so just go in here, play with all these things. This is a table like we saw before. It's a cross table, but it's got colors to help highlight the largest and lowest values. Again, there's a lot to be done, but you can see how quickly I can manipulate data. So let's do another chart for an example. Okay, we're gonna do some line charts. So we're gonna take years up here to the columns. And I'm going to select null and exclude it. I don't really want anything not associated with a year. And then I'm going to take salary to the rows area. And it automatically gives me a line chart when I do that, because that's kind of what makes sense. So now I have a very basic line chart, but maybe I want to see something a little more interesting. I want to see the team separated out. So I can drag the team stuff over to the detail area, and then I get a line chart for each team, which is a lot. If I want to separate these out by color, I can take the salary and color it, so it, and then I could change that coloring scheme if I didn't like it. They change it to red. So you can kind of see the darker lines stand out for each year. And then let's see, I don't think there's nothing really that special about the gradient in this case, so I'll just leave it. Let's see, what else could we do? We could create filters. So we could create a filter for position and only look at one of the positions. And I can show this filter over here in case I want to change this later. And then also I could create a filter for division, which interestingly did not come through. So yeah, we would have to check the data. Hopefully when you guys pull the data in to practice this, it comes in cleaner and your join isn't messed up, because my join is messed up. So let's do a filter on team name instead. Okay, so I'm going to show this filter over here, and then you can also change the style of filter by clicking up here, and then there's a lot of things, but what I want to show you is, like if I want a drop down list or the multiple values like I have, I can kind of change the style. So if I only want to look at like 2 teams, I could do that, or 3. It would have been nicer to, it would make more sense to do it by division. I just, I apologize. I don't know why the divisions didn't come through, but we could create, you know, pretty dynamic filtering. And then if you were to share this with somebody, they would be able to pick and choose kind of how they want the data filtered. So it allows you to drill in and out and filter dynamically while you're looking at the data, as opposed to having to create separate charts each time. Okay. What else can we do in here? Let's do one more chart. So you can rename these sheets just like you do in Excel. You right click and then you can rename them. That would be the right thing to do. I'm being lazy. So we're going to do average salary by position and year. So we're going to drag year up here, either to columns up here or up there, it doesn't matter. And then positions is going to go to the right of year. So year and then position. Then salary is what we're calculating on. So I'm going to put that in the rows section. And then I'm going to change this from the sum to the average. So if you saw what I just did, I clicked on this little caret and I went to measure and I changed it from sum to average. So now I'm just looking at the average by year, by position. Okay, I'm going to add some color. And you should keep your charts all consistent. So I guess I had red and then blue and then blue. I should probably make them all red, but just stick with blue. I'm going to create a filter for position. And I'm going to show it. And then I'm going to hide this field label because I don't want it there. And yeah, so this is the final graphic. So now I have like by each year I have the position so I can see how things have changed over time. It looks like the designated hitters had something interesting going on. All right. So once you're done with all this, you can publish these charts to the web on Tableau Public. And to do that, we could create a dashboard first. So to create a dashboard down here, I've been creating new tabs, but there's this little plus sign with the thing and it'll pop up and say new dashboard. They're really hard to see. So I can click this and then I have the sheets with all the graphs that I made. So I can pull my map in, I can pull my little chart in, and I can pull this thing over. So maybe I want my map on top and my two things here. And then I don't want to see these. So I'm going to get rid of my filters. I don't want them on my dashboard. Maybe I do, maybe I don't. I've decided for this dashboard, I don't want them there. There you have it, a nice little graph. You can play with these containers and do different things. You can add like a text container that says, you know, whatever you want it to. And you can resize it. So you can imagine, you can create some pretty nice, attractive looking dashboards. So when you use the data from your assignment to do this, you'll be creating a couple of different graphics like we just did, and then making a dashboard. And then you can decide how you like it, what looks best. And then to publish it to the web, I actually don't ever do this, and I just closed the thing. The instructions are in the book, but let's see. Why would I have done that? Okay, to publish to the web. Okay, up here, file, save to Tableau Public. And then you'll have to set up a Tableau Public account, which is free, and then name your visualization. And then it'll open up in a browser for you, and you can share that URL with anybody you like, including me for your assignment. So yeah, pretty cool stuff. Enjoy it. Practice taking different variables and trying out color or size, seeing, you know, different ways of looking at your data. If you aren't sure, you can always create a table and use this show me feature and kind of play with this as well. And if you do something and then you try to you try to go back to your table and it looks weird, just use the undo feature. Okay. I do recommend that you name your sheet tabs when you're working to let you know what each of your graphics is demonstrating, because then when you go to put them on your dashboard, instead of seeing sheet, you'll see the actual name of the little graphic that you made. All right, so the last thing we need to talk about is data cleansing. We're going to skip over, here we go. All right, so generally all the data sets that you've been given are already cleaned for you. It doesn't really make sense to take a course and then have your instructor hand you bad data. Real world data sets are not so perfect. And especially if you pull data from external sources like the internet, you can run into all sorts of problems when you try to do any analysis on it. So while cleaning data can be tedious, it's really necessary. We have to do some detective work when we get data files. And even then, when we find data files, it's not always clear what we should do to correct data. So we're just going to look at some examples of ways to correct data and kind of investigate a data set. So we have this data set from this company. It's got a number of problems. We're going to look at some different ways of manipulating this file in order to clean it up. So I need the data cleaning file, which is not here. 1 minute. Chapter 4. See if I can find it. Unfortunately, we might just have to use the slides. It doesn't look like I have that particular file. Okay, we'll make do. Just checking one more place. It should, no, yeah, it looks like they just didn't provide. Like it's just missing from. Sorry guys. Yeah, they just straight up did not give me that file. Okay. That's a bummer. Okay, so you can kind of follow along in your book too. Unfortunately, I won't be able to manipulate the file with you in real time, but basically, so there's a data set that has a bunch of customer data in it, and there's a couple different things that we can do to look for possible issues. So for one thing they say is, okay, there's a field called social security numbers. Presumably all of our customers would have, they're all unique people. So we need them to all have unique social security numbers. So how could we confirm whether or not they are? One way to do that would be to sort the social security number column because it's coming in as like a number. And then enter in this formula where we say if the social security number of one cell equals the same as the cell before it, then return 1, otherwise return 0. And then we would pull that formula all the way down. And it's basically just checking to see, because we sorted from largest to smallest, whether or not 2 of the adjacent social security numbers are equal. And then we could sum and see if we get a sum other than 0. And in the data file, there are, in this case, duplicates. So to find those, we could select the range, and we could do a find and select. We could look for all the ones. So if we click find and replace in Excel, it's in the home ribbon, we get this dialog box that shows up right here. And we're saying, show me all the ones, look in the values, make sure that that's checked within this sheet, search by row. When you click find next, it would take you to the first value of 1. So you'd find the first entry, and then if you clicked next, you'd find the second entry. So if this were our data, we would want to go call those customers, validate their social security numbers and make sure they're accurate. If this data was given to us from some other source and we couldn't contact the customers, we might have to delete those values because we can't trust them to be accurate. Or since social security number is not necessarily used to calculate anything, we could maybe assign them a unique one, but we would really want to make sure ultimately that we got the right data. In this other example, there were birth dates. So anytime we see birth dates, we might want to sort on those. So in the fictitious file that we don't have access to, that I'm going to try to find after class. Let me check one last thing. Yeah, just flat out does not exist. I thought maybe I inadvertently deleted it, but never got it. Okay, so birth dates. We can sort on birth date, and then if we did that, we would notice there were a bunch of people that had the same birth date, like beyond what is normal. If you convert birth dates to text, or to numerical values, you would see that a bunch of people that have birth dates are that were entered as 9999. So that means that in the original source of the data, they didn't have the birth date information. So they used this code 9999, which is a standard code often for fields to put in a missing value. So Excel read that 9999 as May 17th, 1927. So we would have to either get rid of those values or fix them if we could go back and clean the data. So that's another thing, another way you can check validate date data. Another issue with date data is if you convert their birth dates to age, which is a pretty simple formula, then you would see that some people have negative ages, and this is a Y2K problem. So the customers in this file that had negative ages, they were born between 1930, but whenever a 2-digit year is entered into Excel, Excel makes a guess. So if the 2-digit year is from 0 to 29, it assumes you mean 21st century. And if it's from 30 to 99, it assumes you mean 20th century. So for the 12 customers that had birthdays between 1900 and 1929, this was a bad guess. And so they ended up with negative ages because it gave them the wrong year. So instead of 1928, it gave them 2028. and made them -7 years old. So to fix that, you could highlight the birth dates where it's wrong, select replace from that find and select drop-down list, and then replace the -202 with 192. And if you read through the example, they'll explain to you why you would do it exactly that way, but that will replace the date, the year in the dates with the correct number, or the correct year. So that's one way to another thing to check for when you get birth dates and stuff is making sure that the dates got entered in correctly. So look for those 9999 issues and like negative ages. Okay, what else? There's a region column, and there should be 4 regions: north, south, east, and west. However, if you were to filter on that field, 8 things would show up. Each would show up twice. And the reason for that is that somebody manually entered this data and inadvertently put spaces before some of the names of the regions. And so it messes up your filtering. So if you were to go do like a sum by, in a pivot table, sum by region, you'd get 8 entries instead of the 4. So to get rid of the extra spaces, you could use a trim function, which the book talks about, or you can just do find and replace and tell it to find all the spaces in those cells and replace them with nothing. So there's some options there. If you have entries that are interpreted as text rather than numbers, this could be a problem. So in this data set, they tried to code credit card users as 0s and 1s, which means they yes or no's. But if you try to do an average, you get an error. And the reason for that is that these numbers were entered as text. And one of the clues for that is that they were like, numbers should be right justified, but in this file, they are left justified. So see how purchases is right justified, but these showed up. That's a big clue that this was not correctly converted. It was converted to text instead of numbers. So look for those things. To fix that, you can highlight the column and convert it to numerical. You can use, you can enter a new column and use a value function, which converts the text entries that look like numbers into numbers. That's a great way to do it. You could also, you could do that in a new column and then do copy paste as values and then delete the column that you created, just to fix that issue. And then the final thing was the income column. So if we sort the income column from largest to smallest, we would expect to see people's incomes between around 20,000 to 160,000, but some of them will be like very small. Like for example, they look like, it doesn't show it here. Dang, 22. There's an income that says 25. There's an income that says 104, and then there are a bunch of $9,999 incomes. So we have 2 problems with the income. Someone entered some of the incomes as multiples of thousands. So instead of writing 22,000, they just wrote 22. So for those, we could make a reasonable guess as to what the issue was, and we could fix those. We could go back and confirm that that was the error that was made, but we could feel pretty good about just multiplying those by 1,000, or by, sorry, yeah. So for the 999s, that means that they didn't have that information. So we have to decide if we can keep those values or not, or if we want to drop that information from our data set. So yeah, that for those, you have to figure out what you want to do. And then I guess for some of these things, like the data has like amount spent and purchases and stuff. From there, you can also look for outliers, which is something we've practiced before. to inspect the data further. So I'm sorry that we couldn't do that within Excel, but I just wanted you to be aware of some tips and tricks. We are just going to focus for our homework on the power functions within Excel and Tableau. So you don't need to worry so much about the data cleansing stuff, but I do think it's good to have an idea of how you can sort, just thinking about the data that you're looking at and how you want to sort it, or how you could manipulate it in order to inspect it. So like if you're looking at birth dates, I just gave you some ways to kind of validate birth dates and what to look for numerical values like income. Just sorting from largest to smallest gives you a very quick way to see if there's anything nonsensical in there. So, okay. All right, so our discussion again this week is going to be in your discussion board. They are just conceptual questions from the reading and the lecture to make sure that you kind of understand how relational databases work. So you'll just be answering through the discussion board on Blackboard and then responding to your peers by Sunday. So get your responses up as soon as possible if you haven't already. And then I'll be active this weekend chatting with you guys on the discussion board. And if you want to look really quickly at your homework, I will pull it up since we have a few minutes. For your homework. I will post this lecture to help you guys follow along if you need to. I basically just followed along with the book. So you can also, I think it might be easier, honestly, since you just watched me go through it all, to actually follow along in the book with the files if you're still kind of struggling, because I don't think watching me do something over and over is going to be as useful as actually manipulating stuff in Excel on your own. So for your first one, you have this shirt orders access database file. So you're going to open Excel and you're going to pull in some of the fields, but the first thing you're going to do is pull them into an Excel table. So when that menu comes up, when we were clicking create a data connection and then add to data model, instead of doing that, you're going to click the first option, which is table, insert as table, and then not put it in the data model. And then you're going to practice doing some of these imports. Then you're going to create a table from the data by using Power Query. But again, just with everything as tables. So let's see. For query, when you import, you're gonna remove some of the columns that aren't in use, which I showed you guys how to do in that query editor, and then add some new fields and then filter as necessary. So once you do it this way, you'll see like this is the old way of doing it, but then you're going to do it the way that we did several times in class. You're going to use Power Query, but you're going to load it into a data model instead of loading it into tables. So when you do it this way, you won't get a sheet for each table that you've imported. It'll just be in that data model section in the Power Pivot ribbon. And then from there, you can apply the same filters. And then you're just going to do use the Power Query, put it in a pivot table report, and then manipulate the pivot table to show this units for each gender category by quarter. Okay, so you're just pulling in some data and then you're just manipulating it. Just follow the directions carefully. It walks you through everything you're supposed to do. If you get stuck, I'll do homework. I'll plan on doing homework help again on Sunday morning. It has to be morning because I'm, yeah. And then your second is you get a text file. It has the air quality index for LA. Note that each row is supposed to be a date value. So when you pull it into Excel, make sure that you transform those texts into date. And then you're going to sorry. So import it into Excel first and fix the dates, and then save that file, and then use Tableau Public to connect to that file and create a line chart of air quality index by month. So I don't need you to do anything wild in Excel. I just want you to create a line chart. I was mistaken. You don't even need to create a dashboard. If you want to go above and beyond, I will give you some extra credit for creating 3 different, I'm not even sure, actually, before I say that, I should look at what that file even looks like. If you want to create a couple of different types of graphics to play around with the data, I will give you extra credit. If this data file is not, oh, dang it. It's not, it's very basic. Let me see if I can find an alternate data file for those of you that want to do something a little more interesting, because this is just gonna be date and air quality. So you're not gonna be able to do much other than that line chart by month. So yeah, if that interests you guys, I'm happy to find a more interesting data set for you to play with in Tableau Public, and then I'll just send out an announcement once I get this video up on the web, including that additional file. And if you would rather do that instead, then you don't need to do this Power Query part. You can just use the alternate file and then create 3, let's say like create 3 graphics or so, and then make a little dashboard and publish it, and then send me that instead. And I'll yeah, I'll give you, I'll give you let's say an extra 10 points for going above and beyond. So okay, any questions? Or hopefully you guys are feeling okay. That was a lot of information, but I really do hope you go through. If you've done the reading, great. It really helps do that before class. If you haven't walked through some of the examples yet, please at least walk through the larger example that we did and just practice, because the power features in Excel are huge. And there's probably, if for those of you who already do a little bit of analytic type work at your jobs, or who are moving into or hoping to move into jobs where you're doing analytic work, this will put you ahead of your peers, and it will help ensure that you are using the right tools. And yeah, it just, there's so many things that these tools can do. So the sooner you get comfortable with them, the better. All right, and everybody has Excel, especially on their work laptops. So you don't even need all this other stuff to create some pretty powerful tables and databases. All right, yeah, unless you guys have questions for me or anything else that you are shaky about that I can provide more resources, or you can send me an email. I'm happy to dig up some like little tutorials and stuff on very specific tasks as well within Excel. Are you guys even there?
I mean, I'm good. Just gonna try to go, like you said, go through the book examples and then just kind of follow along step by step.
Yeah, the examples are nice. They're very detailed. They'll walk you through like each thing at a time. They have the screenshots so you know what stuff should look like. So again, there's no like crazy math or calculations. This week is just all about manipulating with these tools. So very hands-on, a lot different from the last couple of weeks. So hopefully you guys enjoy the challenge and the change of pace a little bit.
Great, thank you.
Okay, I'm gonna end class. Hopefully you all didn't fall asleep, but if you did, I'll post the video so you can follow along later if you need to.
Thank you.
Bye,
Thank
guys.
you.
Have a good
You're
day.
welcome.
Bye.